All right, about 1 more minute, guys. You're doing 3 on the left and 3 on the right. Any 3 on the left and all 3 on the right, please. And then we'll go over the answers. All right, 30 seconds. Finish the one you're doing, please. I know these are complicated to type. They're also complicated for me to check like this. So some of you I've been saying, oh, that's right. And other ones of you, I'm like, oh gosh, I think that's right. All right, so let's go over them. All right, good, good, good. So some of you will need to check your own answers because I couldn't keep up with all of them. All right, so numbers 1 and 2. Remember, when you have two numbers with the same base raised to an exponent that's being multiplied, the rule is you add those exponents. So on the first one, we bring over our base, we add 2 plus 3, and the answer is x to the 5th. The second one, the 4s are the bases, not the coefficients. So we do not multiply 4 and 4. They're the bases. They have an exponent attached to them directly. So part of our answer is the base. We add those exponents. 8 plus 3 is 4. And there we go. Now the third one, the 2 and the 3 are the coefficients. Okay. They're both raised to the first power. They're both attached to a variable. So we do multiply 2 and 3. So 2 times 3 is 6. And then when we add those exponents, 3 plus negative 3 is 0. So this is the same thing as saying 6 times x to the 0. And hopefully most of you remember, anything raised to the 0 power is equal to what? 1, remember? No. Yeah, 1. Anything raised to the 0 power is 1. So what is 6 times 1? 6 times 1 is 6. So number 3 simplified is just 6. Okie dokie. All right, number 4, you're going to multiply 5 and negative 2, and we get negative 10. And then we take those exponents, we add them, and we get negative 10 times x to the 10th. Number 5, we get the same numbers. I mean, the numbers that have the same base. So 2 plus negative 1 is positive 1. So we have m to the first. Well, m to the first power is just m, right? And then we have our n's. There's only one n on the left side. There's nothing to combine it with. So part of our answer is n to the third. And then we add those exponents that belong to the base of p. So 2 plus 3 is 5. And that is the answer. N to the third, p to the fifth. Number 6, we're going to multiply. Negative 4 times negative 2 is positive 8. Negative 2 times positive 2 is 0. So x to the 0 is 1, right? And 1 times 8 is just 8. So those go away. They just go away. And then 5 plus 2 is 7. So number 6, the only answer is 8 times y to the 7th power. All right, so check your 3. Who got all 3 of them right? Yay, yay. Who got 2 of them right? Nice. And if you missed most of them, I guess, please see what you did wrong and ask me if you have a question right now. No? No questions. Okie dokie. All right, number 5. So the first thing we're going to do on number 5 is we're going to simplify our coefficients. We can divide 4 and 8 by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And then we're going to take care of these exponents. So 5 minus 1 is 4. There's more x's on the top. So x to the 4th belongs in the numerator. We know 2 is in the denominator. And then we have 1 y up here and 4 on the bottom, right? So the difference in 1 and 4 is 3. Since there's the most y's on the bottom, y to the third stays in the denominator. That is our final answer. Do you understand? Okay. All right. Now on number 6, we can, I don't know why this is separated, but 15 times 10 is 150. Okay, so I'm just going to write it like this. 10 times 15 is 150. And then 6 times 3 is 18. So I guess I could divide 150 and 18 by 3. 6, I think 6. Can I divide 150 by 6? 150 divided by 6 is 25. All right, if I divide them both by 6, I get 25 up here and 3 on the bottom. So, whoops. So that tells us our numbers, 25 on the top and 3 on the bottom. So far, so good? All right, now let's worry about our exponents. So we have 4 x's on top, 2 on the bottom. So the difference in 4 and 2 is 2. The biggest group is on the top. And then our z's, we have 3 z's up top, 5 on the bottom. The difference in 3 and 5 is 2. And where does z to the second go? Top or bottom? Yeah, bottom, because this is a bigger group of z's than on the top. Thank you, Hayden. So guys, that's the answer. Who in the world got that one right? Anybody? Yay, Ashlyn. Anybody else? Kira? Nice. Good job. Good job. And then finally, 7, we have a negative divided by a negative is a positive. 8 and 3 cannot simplify. So 8 stays where it is, 3 stays where it is. We have 3 x's on top and 4 on the bottom. So the difference of 3 and 4 is 1. And where does that 1x go? Yep, on the bottom, there's a bigger group of x's on the bottom. So those are done. And then the y to the third stays on the bottom. We don't move it anywhere. All right, how'd you guys do? I got 2 thumbs up and 1 sort of, kind of. Okay. Well, this is being recorded, so if you guys need to go back and watch it just to review these exponent rules, I know that's a lot of rules to learn in a short amount of time, but y'all can do it. You can do it. You can do it. All right, I'm moving on, unless anyone has any questions. Nope. Okie dokie. Perfect. Oh. We already did those. Moving on, moving on. All right, so the last rule I need to talk to you about, there should only be one more rule on your graphic organizer. Is that true? Who printed it out and is writing on it? Hayden, do we only have one more space on our graphic organizer? How many spaces we got? Yes, okay. So the last rule we haven't gone over is called the power to power of a power property. Okay, so basically what does that mean? It just means you have an exponent raised to an exponent. That's all it means. So basically, right here at this first example, right here, if we have x to the third squared, you guys, that just means x to the third times x to the third, right? Well, that's just two numbers that have the same base being multiplied. And the rule when we multiply them is to add those exponents, right? So 3 plus 3, the quotient rule, I'll go back to that one. But yeah, you just subtract the exponents for the quotient rule. All right, so anyway, so 3 plus 3 is 6. Well, that's what happens when you multiply those exponents. So when you have a power raised to a power or an exponent raised to an exponent, the rule says you multiply the exponents. That is the rule. So write it on your graphic organizer, please. All right, so let's look at the second one. We have 3 to the fourth power raised to the third power. Well, that's a power raised to a power. We bring over the 3, we multiply 4 times 3, and we get 12. So the answer is 3 to the 12th. Now, if you put this in your calculator, it will give you a huge number because 3 to the 12th power is a very big number. But we're going to leave it in exponential form. And that's what this is written in exponential form. So even though we can use our calculator for exponents, sometimes it doesn't give us the answer we're looking for. If you're supposed to leave it in exponential term, your calculator won't do that. All right, everyone write down this one on your paper, please. This one, the whole problem right here. I mean, just you don't have to write the answer yet before I explain it, but you will write the answer eventually. But this problem right here. All right, problems like this are easy to make a mistake because people forget that every single number and variable has an exponent of 1. Okay, so if you do not see an exponent, it is a 1. So right behind this 7, there's an exponent of 1 right there. So when you have multiple things in the parentheses, as in more than one digit or more than one variable, like this one, we have a digit and a variable, you have to distribute that 5 to every single exponent, including the ones that you don't see, okay? So we're going to multiply that 1 by 5. That's why part of the answer is 7 to the 5th power. And we have to multiply 5 times 3. And that's where we get y to the 15th power. And I can't tell you how many times people forget that 1 and they'll say the answer is 7 times y to the 15th. And that is wrong, you guys. That is wrong. For the you try. What? I'm so confused. Oh, for the next one? Oh, gotcha. Yep. All right, so you guys try these 3 problems, please. Send me the answers. Ashlyn's already done the first one. Let's leave our answers in exponential form, guys. Exponential form, please. So your calculator is not going to do these for you. Well, you just have to multiply the two exponent. Yeah, you multiply the two exponents. You're multiplying 2 times 4. That's it. Good, Colton. Good, Ashlyn. That's what I was looking for. Good, Colton. Good, Hayden. Yes, Abdi. Very good. Good, Colin. Well, yep. Even the 128, what is that in exponential form? It is, Isaiah. Good. Good, Colton. 2 to the what? Ashlyn, 2 to the what power? 2 is 9. Yep, it is at Isaiah. Good. Good. That's right, Ashlyn. Yes, good, Zabdi. So don't forget that little caret button above the 6. That means you're typing, the next thing you type is an exponent, okay? Good, Hayden. Beautiful. You forgot to put your 2 to an exponent, Hayden. Your 2 gets an exponent also. Zabdi, same thing. Your 2 gets an exponent also. Isaiah, same thing with you. Your 2 gets an exponent also. Oh, but it's not an 18, right? It's a 14. All right, so on the first one, we just multiply 7 times 3, and we get t to the 21st. Very good. On the next one, we're leaving these in exponential form. If you plug this in your calculator, give you a huge answer, which is right, but for exponential form, I just want you guys practicing multiplying those exponents. And then the last one, remember what I just said? A common rule is people forget that there is a 1 behind every single number and also variable. So there's a 1 right there. So you have to distribute the 7 to all exponents. So 2 to the 7th times p to the 14th. All right, how do we do, guys? Easy peasy lemon squeezy? Yes. Sorta, kind of, Darius, a little? Okay, good, good, good. All right, then we're going to practice just a few more of all of the exponent rules. This one's probably the simplest. You just multiply, right? You just multiply a power raised to a power, you multiply. The tricky part is forgetting that that number that's attached to the variable has an exponent of 1. Okay, so here's some more to practice. Just a reminder, on number 1, that 2 has a 1 beside it. We're going to distribute the 4 to everything in all the exponents. So we would write 2 to the 4th times k to the 8th. Okay. All right. So there's 8 more problems on this page. I want everyone to try 4 of them. And one of yours has to be either 8 or 9. Everybody's picking any 4. One of them has to be either 8 or 9. Number 3 should be 8 to the third into the third. 8 to the third into the third. Good, Colton. Colin, I think yours were all right as well. Good, Hayden. All right, one more minute, you guys. Is everyone trying? I haven't heard from several of you. Kaden, I haven't heard from you. Shiloh, I haven't heard from you. Jackson, are you there? Are you there, Jackson? Have you left the building? Oh, Jackson. Where are you, Jackson? All right, so let's look at these. So number 2 up here, don't forget we have 8 to the 4th, 4 to the 16th. I meant, what am I saying? B to the 16th. And then, yeah, you would go ahead and simplify that in a math problem, which is whatever a big number, 8 to the 4th is 4,096. But today, we're practicing just making sure we're writing it right. So technically, this is the best answer for number 2, but I just wanted to see your exponents, okay? Y'all understand? All right, number 3, we have 8 to the third into the third, right? Because each one of these has a 1. Anybody get tricked on that one? Number 4, we have 8 to the third or x to the 12th. Number 5 would be 3 to the 4th times m to the 8th. Number 6, we'd have a to the 9th, b to the 6th. Number 7, now the reason I wanted y'all to do 8 and 9 is because those pesky negative numbers. So technically, this is -5 times -5. What's a negative times a negative? A negative times a negative is a positive. Yep. So if you wrote this, technically that's not right, because remember, one of the first things we did was talk about if you have a negative number without parentheses to any exponent, it's going to be negative. But -5 squared is +25. So either you can keep it in parentheses like this and write the rest of it out, or just go ahead and write -5 squared is +25 y squared x to the 8th. So if you have a negative number to a even exponent, the final answer is positive, okay? So number 9 is -6 in parentheses, which is a big number. I don't know what it is. X to the 16th, y to the 16th. So there's that one. And then number 7, -2 squared is 4. So 4x to the 4th, y to the 8th. All right, how did we do, everybody? Good? Nice. I'm so happy you guys are doing well on these. That's awesome. All right, so Ashlyn said you didn't have a rule for quotient. So the quotient rule is like what we did. We reviewed that first thing, like, I don't know, x to the 6th divided by x to the 2nd. The quotient rule is subtract the exponents. Subtract the exponents. But we should add wherever the biggest group of variables, that's the place of, how can I say that? How can I tell you to make sure you would have x to the 4th in the numerator? But in this problem right here, x to the 4th would be in the denominator. You know what I'm saying? Someone sum that up for us. How do we add that to the rule? Someone clever, more clever than I. Colin, you're more clever than I am. How would you say that?
The bottom one.
Well, just remember the rule. So not only, I don't want you to just think of the rule as subtracting the exponents. I need you to know where the final answer goes.
Oh, okay. Usually I forgot. Dang it.
Just is wherever the biggest group of exponents
Oh yeah, that
are.
one. Yeah, I
Mhm.
got confused. My eye went like, when you gotta bring.
I'm just not saying it very eloquently. Wherever the biggest group of them are, that's where the final answer goes, right? So Ashlyn says, so subtract the two exponents and put it on the bottom only if the biggest group of the exponents are in the bottom. Like this one, if we subtract 6 and 2, we get positive 4, right? X to the fourth goes in the numerator because there's a bigger group of x's on the top than on the bottom. In this math problem, it's the opposite. I put the biggest group on the bottom. So when I found the difference of 6 and 2, I still get x to the fourth, but since the biggest group of them are in the bottom, the final x lands in the bottom. That's a mouthful, you guys. Do y'all know what I'm talking about? Say yeah if you know what I'm talking about. I don't think anyone said it. Yeah. Thank you, Ashlyn. Thank you, Hayden. They texted it at least. Hayden said yes. There we go, Ashlyn. She said, yeah. There we go, Isaiah. All right, let's see what's next, everybody, because we're having so much fun. Okay, so this is kind of in addition to the power to a power. It's just that if you have what looks like a fraction raised to a power, you have to distribute that exponent to every single thing inside the parentheses on the top and the bottom. Okay, so this still goes along with our last rule. So, for example, look at this one right here. X to the first power divided by y to the first power. Well, just like we were doing, you still multiply everything, all the exponents in the parentheses by 4. That's why the final answer is x to the fourth over y to the fourth. You see that? All right, next one, we have 3/5 raised to the fourth power. Well, each of these digits has a 1 next to it, so we're multiplying those exponents by 4. So the final answer would be 3 to the fourth over 5 to the fourth. Now, if you type this thing in your calculator, you're going to get some big old numbers because your calculator is going to go ahead and figure out what 3 to the fourth is, which is 81. It's going to go ahead and automatically figure out what 5 to the fourth is, which is 625, and it's going to divide those or simplify them. Okay, so if you put this in your calculator, it's not going to give you this. It's going to give you some simplified fraction of that. It gave you a huge number. Yeah. So just for today, we're practicing writing them in exponential forms. All right, so let's look at this one over here, guys. So this one seems a little tricky, but remember, every single number and variable has an exponent of 1. So we're going to write 3 to the third times y to the third over 5 to the third times z to the third. Does that make sense? Okie dokie. All right, so you could try these, but I know you guys can do them well. I do want to look real quick, though. I'm going to stop sharing this for a minute, and I want to look at, let's see, tomorrow's math assignment. So let me share this other screen with you. Can you see at the top of the screen, does it say power to power and mixed review? Is that what you see? Okay, so I am going to go to, actually, I'm just going to do the preview. All right, so that's exactly what this is. It's power to a power and all the rules that we've talked about. So let's look at number 1. The good thing about all of these is that they're multiple choice. All right, so let's look at number 1. So first of all, think of that 6 has a 1. Actually, let's just practice typing some of these in the calculator. Obviously, we can't type variables in the calculator. There's a variable key on your on your calculator, but it's not for this. So if you see parentheses, you have to use the parentheses. So everybody, let's go ahead and put parentheses 6 and then end your parentheses. And then we're going to use our caret button and we're going to type in 4 and hit enter. What does your calculator say? Do y'all know how to put it in there? Do you know what the caret button is? All right, Darius said 1,296. Is everyone seeing that number? Awesome. All right, good. And then you know that you have to, those two exponents, you have to multiply them. So what is 2 times 4? So 2 times 4 is 8. Yep. So our final answer is 1,296 times p to the 8th. Okie dokie. All right, so technically we have 2 more minutes. If you want to continue, if you bring this up on Canvas and you want to start doing it, I'll hang out here for a few more minutes, see if you have any questions. And if not, worst case scenario, you'll be done with this assignment and you won't have any math to do tomorrow. Okay, but this is all of the different rules we've studied so far. So if you're going to go, bye-bye, do this on your own. If you're going to hang around, then I'll stay here for a few minutes and see if you have any questions. Okay, everybody have a great day. If you're leaving, I'm going to be quiet. If you have any questions, let me know. Jackson, where'd you go, buddy? Did you leave? Did you leave class, Jackson? There you are. Did you go get a snack? You did go get a snack. Did you bring one for me, Jackson? What in the world? Do you know all these exponent rules? Do you have any questions? Jackson, do you have any questions?
Oh, I'm muted. No, I'm good.
Okay. All right, buddy. Well, you have a good day and I'll see you later.